Hi everyone, my name is Liran. It's my first time here in Italy today, and we're going to talk about Jest, which, as you can see, my slide kind of passed all the tests, so I'm already feeling pumped up. And I feel that it is nothing short of fate that I am here to talk to you about Jest. And does the logo look familiar to you? Yes, it does. Like, do you make the connection? How about now? Amazing, right? Look at it at a different way. All right, cool. So it's fate that we're here to talk about Jest. Like every developer in the country should have, it's like by law to just work with Jest. All right, so what we're going to talk about today in Jest is a little bit different than just matchers and expectations and how to set it up. I want to try to give a different perspective on the mechanics of Jest, like how it works and like the reasons that I love Jest around everything that it's structured around. So just to start off, maybe just a few things about myself. My name is Liran Tal. Oh, it's a bit slow. My name is Liran Tal. I'm from Israel. A lot slow. A lot slow. All right, I think we have some connection problems. Okay. Wasn't tested very well, I guess. Okay, so let's see if this works. Okay, awesome. So my name is Liran Tal. I'm from Israel. I'm an engineering manager at Nielsen. I love open source. I love building things. I love security, which we'll talk about tomorrow. And I want to really ask you, let's hide this. So I want to really ask you, can we forego testing, right? What is the role of testing? Why do we even write tests, right? And some of you can maybe figure out and say, it's to be cool because it's fun to write tests, or no one actually says that. Or maybe because our managers told us so. Something is really weird with the presentation. Sorry, okay. Or maybe it's because we just test to see that the code works, or because we want to document our code. So all of those are maybe reasons why you write tests. But ladies and gentlemen, they are not the sole purpose of writing tests. We write tests in order to enable refactoring, right? So we can do modifications to our code, change our source code, and make sure that everything is going to work well and compile, and we didn't destroy anything else. It's basically to have this confidence that we can run fast is changing our code without something that will fail in the end. So this brings me to another question, which is, should we always write tests? What do you think? Okay, so even for small side open source projects, something you're starting off new. So because we're all software engineers here, I made like an elaborate research, and I came up with a scientific answer for you about it. So yes, we should always write tests. And there's this guy, Robert Martin. You don't want to piss him off, so just always write tests, or he will hunt you in your dreams. Or everyone likes beer, so anyway, always write tests. All right, so before jumping into Jest, really, just one final topic I have to touch around testing, and this is the testing pyramid. And I want to emphasize, the importance of the testing pyramid, right? Like, why is it for? So it's there to give us, a testing strategy structure, to give us, the basic foundations of unit test, followed by an integration and end-to-end test. But why is it structured in the way that it is? Right? And there are a couple of reasons for this. First of all, you have to understand that as more as you climb up the ladder of the testing pyramid, things start to become slow, right? Unit test is pretty quick. It's supposed to be really quick. If it's not, maybe that's another problem. But as you go up to integration and end-to-end test, or acceptance test, things become slow because you need CPU, you need resources. You're bringing up a machine, maybe somewhere, testing your process or your project from outside, instrumenting it, and going through some phases of functional testing. So things become slow. The second reason for that is because there's a cost to it, right? When you run tests locally, there's not a problem. You just run them. It just works locally. It's pretty fast. But when you need to now provision this staging machine to run all of your QA tests, your end-to-end tests, that's going to incur cost for you to manage this data center or this an AWS or a private machine or whatever you choose. Now the thing is with the testing pyramid is I've recently seen different kind of references to it. Like one of the bad practices is if you notice that you have like a flip down testing pyramid, which is kind of like an ice cream cone, right? You have small tests, but unit tests, and then as you go up, you have a lot of those end-to-end tests. And it's kind of familiar in places where organizations have like specific QA teams, and devs aren't empowered to write tests. But that's exactly the problem because as we saw, as you go up, you get more slow and you get more pricey. The other thing I noticed recently about the testing pyramid is people refer to all the automation tools like the static code analysis and ESLinters and stuff like that. So they add it, as something that goes below the unit testing, which is okay. It's like a clouder. But the thing to remember is you don't want to have, static code analysis or linters running instead of your unit test. This is definitely not something you want to do. So let's talk about Jest for a little bit. So Jest is kind of a little bit of everything. It's made up of all of those stuff. It has an assertion library, a mocking library, all of those things that you get outside of the box. But what it's maybe a little bit more than something else is it's a platform. And this is why I really like Jest, because it's built in a way that is so modular and extensible. So you can take the Jest runner part of it that runs your test and use it to do something else in parallel with your files for some other projects entirely not related to tests. We're going to see more of that in the next slides. And just jumping into the test framework itself, and this is part of my reasons to love it, and I noted down like 4 items around it. So first of all is zero configuration, which I'm pretty sure you heard of. We've been seeing this more and more. I think the Parcel team kind of pioneered or kind of made that term viral, and then Sean Larkin was coming into the picture with Webpack 4 saying kind of the same thing. Well, Webpack is complicated, it's hard to set up and all of these configurations, so Webpack 4 is going to just work outside of the box like a magic. We've kind of seen this also with Create React App that came into the picture, and it kind of did the same thing, but for actual projects. So with Jest, you also don't need to go ahead and choose your assertion library or your mocking and everything. It's just going to be bundled everything together for you. And the next thing I want to talk about is just being fast, with people choosing it just because of that. So I call this, fast like Ava.js, which is another test framework, but sane like the rest. And we're going to drill down into what exactly I was trying to say there. So Ava and Jest kind of share the same feature or a similarity where they are running tests in parallel. So essentially, just what it does is it figures out the amount of available cores that you have, and it tries to run all of those tests in parallel. So when you run it from the CLI, for example, you could see something like this, and all of those test files are set in parallel. But it actually does more than that. It tries to optimize so you can have your slow test running first. And let's think about why that is so important. Because imagining that this is a test run by Jest, there's 2 cores, for example, so you have 2 workers running there. But what happens is if you just ran randomly files between the 2 workers, you might get into a situation where your slowest test actually ran at the end. And what would happen in that case is, and this is what the Jest team actually observed, is the second worker is kind of sitting idle there, not doing anything. So Jest is smart enough to figure out what tests are slow, and then it goes ahead and does this optimization where it queues up all the slow tests first, so you can start running them, and then both workers are kind of juicing every bit of CPU that you have to make things really run in parallel and fast. And this brings us into something called sandboxing. So sandboxing is something that is, again, shared between Ava and Jest, and it kind of happens, between because of the parallelization of the tests. So basically, because you have specific workers, executing to run a specific part of your test code, you have this kind of isolated environment where it's a new node process running all of your JavaScript code, and there's no leakage between the 2 tests, and there are no memory leaks, there are no global shared variables that you can do between them. It's kind of giving you a sandbox. So the last thing maybe that Jest is doing to kind of optimize things is being able to cache all of your transformations. So If you're doing front-end work, for example, with Jest, maybe you're trying to make transformations to CSS or SVG files because you don't really need the actual bytecode for that for the actual test itself. So more than that, maybe you're bubblifying all of your test code or your source code, and then again, bubble is again a CPU-intensive task. So all of those tasks being made, all of these transformations are being kept on the side, and whenever it just fires up, new tests and new runs, it knows which changed and which not, and then it can just reuse something that was already transformed and not do this whole transformation again. So all of those kind of pile up to optimizations that Jest is doing internally to run all of your tests as fast as it can. But this doesn't really bring us, to boil down to figure out what does it mean fast like Ava, but then that it's kind of the same like the rest of them. So with Ava and Jest, they parallelize everything, but Ava really parallelizes everything. And what I mean by that is Jest parallelizes by default your test files, right? But what Jest does, it actually runs your test files and also parallelizes all of your test cases. So all of them are also executed. All of the test cases inside your test suite are executed concurrently. And this kind of brings us to question if speed is, that important, right? And speed may not be everything for you, because even if you have, like, say, 2 or 3 test files in your small project, you would not really get any insightful, gains of speeds from just using Jest, right? Because just spawning, 2 worker processes, it's the memory management and CPU management and RAM and everything else. So all of this already incurs some resources from your machine to do that. And if you think about it, Facebook has a monolith, code base to run all of their thousands of tests, but not all of us are kind of in the same category. If you kind of drill into that a little bit more with insights, you figure out that we are breaking out of monoliths anyway to microservices. We are breaking out from front ends to micro front ends as well, right? So it brings us to the fact that maybe we have thousands of tests, but they are kind of split also between different teams and projects and repositories. So speed is not everything, and pitfall 1 that kind of relates to what happens with Ava. So this is a code example of 2 test cases. Yeah, everyone are happy they're now seeing code. So you can see the smiles, developers. So so this is an example with Ava where you have 2 test cases with assertion, and there's some library there that's trying to do something different, maybe based on the 2 node variables being having different values. So I wrote the same test with Jest. You can see that the test concurrent kind of flag there that Jest can actually run those tests concurrently. And what's going on is this service logic dummy is using a configuration service abstraction to get a configuration, which that abstraction just uses the node n variable, right? So if I add that in the test, and again, I have 2 test cases that are kind of, the service logic is doing the same thing, but based on an environment variable, and I try to run it, it looks like it's working really well, right? You go and it's like, hey, concurrency, even on the test cases, amazing, let's do this for everything. But then if you did something a little bit more in one of the test cases that just took a little bit time, and you have like mutated the state between the shared variable, you would see that when you run the test, you now get different results, right? Because we mutated the state, we mutated that global shared variable, and now the racing condition happens, and the test fails. So I really love Ava. That's how I started actually working with Ava at first, and for me, like, this is how it felt like at first. It's like amazing, but then like going in through a wall. So it's really cool, and you can write concurrent tests, but it kind of requires you to write them in a good way as well. So brings us to abstraction for the masses, right? This is what we just saw. We saw a service logic using some kind of a test, sorry, not a test, sorry, using the configuration service as an abstraction layer to be able to do that. And if we wanted to actually test that in a good way, we would be doing, be able to mock that specific configuration service to drive our code into different paths. So the second pitfall that I've been saying is people not really understanding what parallelization mean with Jest. Like, I was doing this code review, and you can see there's like the test case has 2 assertions beneath it, and the developer who did that said, well, I'm doing it. I asked him, why are you doing that? So he did, I'm doing it because everything is in parallel with Jest. And it's not really the case, right? Because with Jest, you just have the test files as parallel, but the test cases in themselves, they are running serially or sequentially, basically. So the next thing around the test framework is basically the matchers. So you have, to be truly, to be null, everything kind of makes sense, the same stuff that you see always. But then you have cases where you need to check is array, to be truly, and we're here using a little bit of the JavaScript syntax, and it feels a bit clunky. So what if we wanted to add more custom matchers and do something that's a little bit nice? Like what if you had an assertion of, to be array, or for a number to be even? So all of this stuff happened because Jest allows us to do this and customize the Jest matchers, and it's more semantic, it's more verbose, it's more readable. So code mods, if you haven't heard of that before, just a small story about it. It's basically a way to refactor your code in an automated way, and Facebook has been doing that in several types of evolutions. The first one being they started doing regexes replacement from source code 1 to source code 2. And then this evolved into something called JS Code Shift, which actually does AST transformations to your code. You run scripts, you give them input, and you give them output. And this brings us to the ability with the Jest community to enable us to do Ava.js and tape and everything else into Jest, because it knows how to do those transformations. It's not a very easy phase to do. There's nothing really automatic about it, and it's not all roses. I wrote a story about it in Medium, so if you want, you can read it later. And finishing off, anyone know who this is? I don't know either, so let's continue. Right. So another set of reasons I love about Jest is the developer experience behind it. So let's talk about the logo. No, I'm just kidding. We talked about that, so let's continue. We talked about it. It's nice. All right. So the visual diff and verbose and the effective verbosity that you have in it. And if you start to look into it and you start working with Jest a lot, you start to appreciate it, because if you imagine this just a typo in the code that you had and you ran your test. So before in the team, we started using tape. It was something that was kind of standard in the team. And this is kind of tape out of the box, not configured with anything, but it's really hard compared to Jest to figure out what was going on. And this is where the developer productivity around Jest kicks in. There's kind of the same experience that you feel as empowered developer when you're trying to even compare to strings. So this test case, for example, has a bad assertion between the expected and actual. So while Jest shows it in one way, tape shows it in one way, Jest is able to show you something a little bit richer. And even if we bring that up a little bit more, you have nested objects there, and with Jest you would see this very clearly. And this is what Jest has been making in the industry. It's like if you have worked with Jest for one time and you see that screenshot itself, you don't see Jest anywhere, you know it's Jest. This is already a trademark of working with Jest, and this is how it kind of revolutionized the testing. So going on to the third element, relaxed conventions, which I also like about working with Jest, is it's the little things that matter most for us when we work with it. For example, even the CLI, before going into immersive watch mode, whatever that means, you just run it, you have a typo, it's going to tell you, hey, did you mean maybe watch, minus watch, you have a typo there. And Jest is built around Jasmine, or was for some time, and then they forked it and made some changes, so everyone kind of knows BDD. But then you start working with Jest and you start wondering, well, should I have a test case inside a describe? Can it be just test? If I'm coming from tape or Ava, can it be eat? Do I do feat, or do I do eat only? Because those are API changes between Jasmine. So the thing is, who cares? Because Jest already has your back, right? It has LDSs for them, so it doesn't matter what you're used to. All of those are going to work outside of the box. So again, developer experience and productivity is getting a boost. The file naming convention is a small thing, but this is, again, different between different frameworks as well, and Jest kind of knows how to find all of those together. And when I've been working with Jest for a while, I've actually had this kind of a relief. I felt, wow, look at that, amazing. A JavaScript framework that actually tries to fight JavaScript fatigue, right? They're making it easier for us, not harder for us. So gonna maybe end up with the immersive watch mode for this list. And what is immersive watch mode? So this is what the Jest team think it means, right? This is what the Mocha team thinks it means. They're not too happy about it, as you can see, because they don't have it. And this is what my colleagues think it means. They are too happy about immersive watch mode because no one knows what it means. But this is what it really is. So except of all the stuff that you get from the immersive watch mode, what Jest does is automatically resolve all of those running test files automatically for you. For example, it's gonna, of course, just watch the files and run all of those that changed. Then it's gonna hook up into your Git history and figure out what commits were added, so it can diff it and find the related test to the source code and then run those. It will find all the failed tests first. And once it does, it will run the fail test first to give you a basic feedback loop. And I don't know if you noticed it, but it also gives you an estimated time, because Jest, will see this next, in the lifecycle, is actually able to record what's going on around your test. It actually knows what was your last runtime, so it's going to try and give you an estimated runtime for the future. And all of that is except of just being able to just run a specific test with the CLI, or just run your fail tests and dive deeper into this. And when you think about the CLI and running stuff in parallel, so this already becomes complicated, because if you're running several test files and you have like console logs inside them, what are you going to see, right? It's going to be a mess. So Jest understands it. What it does is it buffers all of those console log statements and groups them on. So like when the test finishes, it's able to tell you, hey, it was this and that console log from this file and that line, and it groups them up per the test cases. So here's a pitfall that happens when you're debugging tests. And when you've worked on it enough time, you've noticed that there's like you're trying to debug a failing test, and you have like an it, or a focus describe or focused it, which says like, I just want to run this set of test cases, and you do this basically because it takes a lot of time to run all the other tests or something like that. And what happens is we fix the test. Hey, now it's passing. But what happens is someone committed that to the repo. And no surprises that the test passes. So whenever that happens with a team, I give this sticker to someone. It's very useful for them not to do it again. And just again, the immersive watch mode on the CLI kind of helps you with all of that, right? It tells you which tests were skipped, and you can also see like a regex of what I was trying to run specifically. So if you think about it for a second, you don't even need to run a focus test and like change the actual it only in the test code itself. You can just go to the CLI, say I want to run a test case named like this with a regex, and you got it running. You don't need to commit anything by accident into the repo. So final thing before we move on, the last subject basically is around the Jest testing lifecycle, right? And let's try to understand what Jest is actually doing there behind the scenes for us. And I'm going to start and talk about it from bottom-up experience. So for example, we're going to talk about the test suite structure, what it means scoping for when you're writing tests, and the test runner itself eventually. So a single test is pretty basic. You can either have test by itself, or you can wrap it up with a describe suite. But you also cannot do nested test or it, because those are actual tests, so it doesn't really make sense to do that. The other thing is that you can do is you cannot have nested before or after each elements, because again, these are something that you cannot nest within each other. But if you think about it, what you would be able to do is, if you have this kind of test suite and you have before and after all, that makes sense. But what happens if you had several of them? Is that even possible? What would happen? So what happens is basically if you add all of them, this is just for illustration purposes, but just kind of reads your test suite. It queues all of them as in the order that it saw them, like serially, and then it's going to run them one by one. Yeah. Okay, so going on to scoping. And in scoping, we have a different question. What if we have nested describes, right? And we have before each at the top one, and then we have, for example, before each at the bottom one, and the nested describes. What's going to happen? Are we going to run the top one also in the bottom one? If so, when is it going to run? So hopefully animation getting a little bit easier in this screen. But what happens is basically each nested describe or suite is getting run as itself with everything in it, like before each test and then after each. When you get to the describe block, all of those are also going to run first, all of the three statements there, but they're going to be wrapped by the top level before and after from the upper describe suites. So this is kind of related to scoping around your tests and how you would get results that you would expect and not something weird going on there. Yeah. Right. So lastly, I want to just focus on with Jest about how it would handle running, a suite of tests in terms of parallelization. So how Jest works in general is, through this diagram, if we walk through it, first of all, you have the ability to set up globals. So if you want, for example, to expose some kind of variables to your test, you can, CI, dev, staging, whatever, you can just define that in the configuration, and that works. The next thing that you might want to do is set up, something that's a tier up, that script that runs before everything else. It's asynchronous, so you can use it to write, for example, maybe like fire up a database or clean it up, because this gets run before everything else gets run. So it's useful for those reasons. And then you have the actual Jest runner module, which just goes ahead and run all of your tests, which can run either serially or in parallel. And what it does is it basically also gives you an ability to hook into the Jest lifecycle, which means I noted down just one, but there are actually two of them, which you can have a script run before every actual test file, right? So a script and test, a script and a test file. And this gives you several abilities. For example, if you need to polyfill something like local storage, which you don't have as part of your test, or if you want to extend the matchers that Jasmine give you and put your own custom matchers. So for both of these options, you have like two different configurations. This is one of them, which runs before each test file. So the way it looks like is the Jest runner basically spins up a worker setup model, which sets up enough workers to run the test. And then before each file, the test file itself, which is file 1 and file 2, you get that script getting run. It's not asynchronous, so just keep that in mind. And this kind of brings us to caching, right? Because after all of those tests getting run, and maybe caching is kind of a maybe bad word for that, or storage, or we can basically store all the information and stuff that we collected when running tests. So for example, we can figure out which test failed, right? And then we can queue them for the next run, which tests were the slowest, and we can queue them up for the next run, which kind of brings you to think, well, what happens when you run Jest for the first time? You didn't run anything. How does it know which test to run? There's nothing slow because everything is still fresh. So what it actually does behind the scene is it checks the file size. So if the file size, the test file size is really big compared to other files, it probably means it will be slower, right? It's not really perfect, but it's a good indication of that. So it's going to take that big file and queues it up first, and then for subsequent runs, it has all of this information that it has. So finally, I think we're going down to the tear down command, which allows you to basically, just like we did with the tear up, set up some command that will run synchronously, and of course makes sense because maybe you need to clean up some files you created, you need to bring down the database after you brought it up, or some other service, and this kind of finishes up all of the testing lifecycle from a very high level kind of view. So talking about everything and just keeping a small comments in mind around all of this. So first of all, you need to understand that resolving the test files, even if you run them serially, it's not something predictable. So like you can tell test, I want to run all of those files one after one. Don't parallelize everything. But Jest doesn't just going to run them by file naming conventions. So I've seen it around a few times around where people have test files named like 01 something 02 something because they're trying to make steps out of the tests. But that doesn't work. It doesn't even work predictably if you use the run in band serially option. So keep this in mind when writing those tests. So I think we're almost done. So give Jest a try, and I hope you'll fall in love too. That's it.